Okay, welcome to today's video where we're going to be putting together this circuit board right here. This circuit board is a test set for the little J1850 variable pulse width modules that I sell. We're going to be able to test the communication feature on it and the power supply that powers it in this project. And so today's video is sponsored by JLC PCB. So we're going to take a quick look at today's sponsor and then we'll get right into it. So from today's sponsor, JLC PCB, we'll be featuring a stencil with frame from them and a 2-layer circuit board that we're going to be assembling. Now, this isn't all that JLC PCB has to offer. You can get them to do 3D printing, metal 3D printing. You can get multi-layer circuit boards done. You can get flex circuit boards. You can get circuit boards on specialty material like Rogers, and then you can even get them to do the assembly. The only reason why I don't have them do the assembly for me is because it's part of the project I enjoy, but I have used their assembly service before and I was not disappointed in what I got from them. So yeah, definitely check out today's sponsor, JLC PCB. At the time of recording, and hopefully by the time I release this video, the Black Friday sale will still be going on. I believe it ends December 15th. But yeah, take some time, check out today's sponsor, JLC PCB, and thank you to them for sponsoring today's video. So yeah, let's get into today's video, and I'll start out with actually showing how to use one of these stencils without like a special jig or anything. So let's take a look real quick at how one of these framed stencils would be useful. And you know, you may have heard these called silk screens before because you kind of use it like one, but I tend to use the term stencil for one of them. So all we have here is a piece of waste board with the circuit board just kind of taped there so it doesn't move. And then we use this framed stencil that we got from our sponsor JLC PCB to put down our solder paste. So all that you're going to need for this is really the stencil, solder paste, and some sort of scraper, spudger tool to spread the solder paste. Another quick thing is don't forget to wear gloves with solder paste because, you know, this, especially if you're using leaded solder paste like this, you definitely don't want to ingest those small solder balls that are in there. This is one of the few times where leaded solder is something you need to actually be really cautious with. You know, your normal spool of it, it's pretty hard to actually end up ingesting as long as you wash your hands. But this kind of stuff you're going to want to wear gloves with, just because it's so small, it really can get trapped under your nails and stuff. So just take it and line it up. Sometimes it can be kind of tricky to line up. We are decently lined up here. So let's go ahead and get a nice amount of solder paste here on it and just kind of start spreading that around. Now, before you actually lift, you're going to just want to look real quick and make sure that everything looks like it got evenly coated and that you're not seeing that shiny finish under there. So when you lift, you're going to just want to go straight up with it. And hopefully you didn't take all your solder paste off with it. As long as you're using pretty decent solder paste that hasn't dried out on you yet, you should end up all right. And that looks like we did a decent job here. So there you go. We have a nice thin layer of solder paste throughout on here. And we can start putting components down on the board and use hot air to solder them on. You'll notice that that stencil didn't have any holes drilled in it for the through-hole components. Sometimes it can be nice to put like a fiducial hole or something to help line up the board. But yeah, let's go ahead and just start putting the components on the board. Okay, so let's do something a little different in this one and actually voice over instead of play some background audio. So when you're assembling a board like this where you use the solder paste, you just put the components on one by one, or really by design this would work with a pick and place machine and you would use a pick and place machine, but I get to be the pick and place machine in this case. So I'm gonna put all these components down one at a time and do my best to line them up. They don't have to be lined up perfectly, because once you put these in the reflow oven or you use a hot air station, the surface tension of the melted solder is really gonna pull most of it in place as long as you have it close enough. When you hand dispense the solder paste, like without a stencil, when you put it on there by hand, sometimes it can be difficult to get this to work in an oven. The components are going to want a tombstone because you don't get the right amount. But with a stencil like we used in this video, you generally can just put it right in the oven and not have a problem if the footprints were right. I do like to use the hand solder footprints because they're easier to rework. So the footprints are bigger than normal. So you still kind of have problems with tombstoning with a hand solder style footprint where it's larger to allow you to get more heat in. So for the long-term viewers of the channel, if you've been wondering what's going on, where have I been? It's just that I've been busy with school. So I've been finishing up my college degree. I took 2 classes this semester, and the AutoCAD class was just very drawing heavy. I was doing a lot of homework, so I just didn't have time this semester to do videos. The semester's wrapping up now. I'm finished with AutoCAD. I just have to do my exam on my PLC class. Next semester, I only have 1 class to take, so then I should be done with my degree. Should have some more time to do videos. The channel, we should start to see more content. I don't know when I'll get back into automotive electronics as much. I don't have a project car, so I don't have anything to kind of keep my interest in on those automotive projects. But I definitely have some repair projects in the works. I have some broken power supplies I need to fix and some broken loads that I need to repair. So I have some test equipment content coming up for you guys. So yeah, let's finish this up. Okay, so let's do some mechanical assembly here. So yeah, the circuit board lines up like that. Then we got a spacer, and then finally the latch that goes here. So first thing we got to do is put these threaded inserts into the base plate here. And the way I do this is I just use the conical tip on my soldering iron, because I really don't use the conical tip for anything else, and set it pretty low. So I got it set to 210 degrees C, and then we just heat these up and melt them, and then they will kind of sink in there. So the brass insert melts down into the plastic. I normally try to space these holes a little bit larger than this, but I guess I messed it up. I normally do metric inserts, but this one's number 4 on here. I just had some number 4s on hand, so that's what I went with. All right, so as you can see, we line up nicely with all of them. I mean, I just bumped it there, but yep. So they line up. Don't worry if you do screw up and like your holes aren't deep enough, or if they're like this where they weren't quite wide enough. You can generally just turn up the heat on your soldering iron a little bit hotter than what the PLA is meant to take, and get them in there. Anyways, I stayed at 210. That's why I was pressing a little bit longer. But yeah, these holes weren't quite perfect, but they work. So let's go ahead and get this on here. All right, and the spacers are mostly just to help prevent smashing down on that. So again, board just kind of sits here on the pogo pins, and then we have the clamp that comes down and clamps it down. So let's get that mounted on next. And yeah, so they are not beyond flush, and that is really all there is to it. It's nice and simple. Let's see how well it's lined up right now. Probably have to adjust this some. It actually pushes it down okay. It's a little uneven on the pressure. We aren't bottoming out any of these, but let's see if we move that some. Yeah, that's a little more even. So now that we got this thing assembled and got the mechanical assembly going on here, let's take a closer look at it and see what's all going on. Off camera, I did change how the standoffs are. I just took that standoff off because it doesn't come even close to touching it. And then I used a screw and a nut to kind of set the screw. And it's just to keep it from tilting this way. This lever wants to kind of tilt it towards itself. So that's just to stop it, to keep it from bottoming out on this test probe right here. We have a generic lever clamp and then a 3D printed base with a spacer to kind of space this up, and then generic test probes you can get off of Amazon. And then the rest of the circuit is kind of an Arduino and it's an isolated RS-232 with some measurement and control of this guy here. So this test probe goes to the test point on the bottom of the board that is the output of the 14-volt power supply. Comes over, you have that jumper that you can jumper if you want to get the 12 volts out, which is really closer to 14 volts. It's just like automotive power. So yeah, pretty simple concept here with just test probes and another module for it to communicate to. That's why there's the second one. So that way I can receive and transmit with this one and verify that the data is actually good. We had a couple of mistakes in the board layout here. I got the pin order wrong on the FET that drives the relay here. And I used a relay instead of a MOSFET for turning it on off, just in case I had one that was like shorted out. It wouldn't blow the FET. You know, the relays are a little more robust in that aspect. So yeah, the MOSFET, I had to kind of rotate it on the pad because I got the pin order wrong on it. Another couple of mistakes I made, the clock pin for the SPI was not connected. I had like, I don't know, 0.5 millimeter to 1 millimeter of it not connected. So when I was looking at the net list, it looked good. I should have run the software to check it for that though. And then the net from the isolation chip here, I accidentally attached it directly to the reset and not on the other side of the cap. So the other side of the cap was floating. That was a mistake I made at the schematic level, so it just translated into the board when I did that. So I had to cut that trace and run a jumper to the other side of the cap. And then not a mistake in the board, but just an oversight in the fact that when you would cut on the relay and charge this cap, and then that would start charging that cap, it was enough power that it would cause a brownout at the microcontroller, and then it would just start resetting over and over again. So to fix that, I added some capacitance over here that I just kind of jumped across the diode there, and then I also added a electrolytic cap here on that header that was there for if I wanted to do an LCD. I wasn't sure how I wanted to do this project, so I kind of allowed for both, but I know the direction I want to go with it now. So the run button and the header for a screen are not going to be used because I was at first just going to just, click a button, it runs a test, and then it tells me if it's good on a screen. I changed my mind about that and wanted to communicate with the computer so that way I can generate a report instead. That way when I ship these, they can come with a report on how it performed on here. So that is the direction I want to go with it. And then once I get into doing the video here, I'm going to take R10 off just so that way this LED isn't lighting up. The LED messes with the focus on the camera and it's just going to be lens flare for you. So R10 I'm going to disconnect for now, but it's just an indicator of if there's power on the board or not. Oh, and one other thing with the board here. This is the first time I used the footprint for the tag connect to program it in Circuit. Although once I put the bootloader on the chip, I just program it in Arduino over there. I do have to do that initial flash to it. I wanted to try out this footprint with the tag connect. It uses some little studs here to line it up, and then in the center there you have 6 pogo pins or test probes to program it, and it just snaps on like that, and then you can plug into the computer. I'm just using an Arduino as in-circuit programmer to program this thing. But yeah, it's super convenient. It's a really small footprint and no parts to have to put on the board. So yeah, I'm definitely happy with the way that came out. So yeah, let's take a glance at the code and then actually get it up and running. I'm gonna try to keep the overview pretty brief here. It's basically a copy of the firmware that I did that worked with the Visual Studio project that lets you use one of these kind of like a debug tool for CAN bus. So a lot of it just came out of that. The main differences here is I have the control for the relay, and then those 2 ADCs that I'm looking at. So yeah, as you can see, it's basically a state machine, our default state standby, and then we have all of those same little functions that you'd seen in the other ones where I talk to the chip and initialize it and all of that. So yeah, we're going to look for these particular commands and then do something based on the commands. We set the state, go into the state. Pretty much all of the states exit their state after they've done what's in it, except for the RX for either the test set or the RX for the controller. So those 2 stay in their current state and don't exit until they get another command. So yeah, we have this case statement for the different states. So I just used a case switch for my different states. And then we have these functions that we can call. So it's really simple. And as you can see, like a lot of this is just copied straight out of the other ones. I did make a change to it where the SPI cycle is looking for a device to talk to, since I have 2 different ones of it that I'm talking to. So yeah, I mean, it's very, very familiar if you've used any of the other code that I already wrote for this. And again, these really aren't like perfect libraries for talking to this module. I'm just not necessarily that good of a programmer to write you a nice library for Arduino. So it's more of just, I'm just talking directly to it. So yeah, that is the code. Let's actually turn this thing on and see it run through a test on it. So we're just going to use the serial comm and talk to it that way. And then maybe in the next video on the series, I will show, I'll do a Visual Studio project on like actually talking to it and generating a report afterwards. Okay, so we're all connected. We have the USB port going to the computer, which allows us to connect to it over serial. We have 5 volts coming in from a bench power supply. So let's now go through and actually run through what a test would look like. So the first step would be to turn on the relay to power the unit under test. So we will just type relay on into the serial monitor. We'll probably want to measure our current to make sure that we're not feeding into a short with that little current amplifier that goes up to one of the ADC pins on the Arduino. So you can see that we are way down in the dirt. It doesn't take very much power to keep this thing on, which is why I'm using a 50 times amplifier on the current shunt there. And then we can measure the voltage, measure volt, and we get 14.2 volts, which is about right, coming out of that power supply that is on the module. Next, we will need to initialize the module. And now it's initialized, it doesn't send back any state for that, or a statement that it completed it. And then we will want to check that it can transmit. So let's do the UUT TX command. It's going to say that's ready to send, and then you can send a frame. So we sent a frame, and now let's check with the other module, the one that is on the test set permanently. So that one would be TS:RX. Is that command, and we don't have to initialize that one because it is initialized on power up. So that would conclude like a test. We could also verify that the TX and RX is working. So let's just clear the buffer here. All right, test set. TX, it's ready to send. We'll send the same frame we sent earlier, and then RX that. So UT RX. And there we go. We can see the frame that was just sent by the other module. So that really concludes like showing the functionality of that. That is the full functionality and kind of how a test would work on here. We could have, we may want to add the flush command to this, just so that way I can flush the buffer after I write with it. So that way I'm not seeing my own frame. But yeah, I mean, it covers all the bases for the test. So just to turn off the module, if I wanted to like kind of continuously use this thing, it would be, relay off. And now the relay has turned off, it's opened back up, and I could safely remove this from the test set and continue on to the next board. Okay, I hope y'all enjoyed today's video. I know I didn't show everything about this project. I didn't show some of the mods, and I mean, I still haven't even cleaned all the flux off the board. It'll happen. I will clean it up. It's just been quite the project. There's actually a lot going on here. There was a lot of code and just a lot of correction I had to make on the board, and I am still pretty busy. But yeah, definitely check the links in the description for the sponsor, but also if you want to support me, you'll be able to find these modules for sale. You'll find the GitHub if you want to do something with one of the modules, and you should find some Amazon links of some of the stuff that I actually used in the video. So yeah, I hope you guys enjoyed it, and I will see you in the next one.